Welcome to solverfy.
This is the answer to Chapter 26, problem number 47 from the Smith Organic Chemistry textbook. This problem asks us to draw the product formed from the ring-closing metathesis of each compound. And then also we have to devise a synthesis for each of the starting materials from benzene, alcohols with less than 5 carbons, and any other organic or inorganic reagents that we need. Okay. So the ring closing metathesis product here for A is going to be a second 6-membered ring. So that's going to look like this. Try to draw that a little better. Okay, so there's our first ring. That's not going to change. The position of this oxygen is going to be the same. And then we will have just a 6-membered ring here with a double bond right there. Okay, and so that's the ring closing metathesis product. In order to synthesize this starting material, we're told we need to start from benzene. And so let's do that. And we can do a Friedel-Crafts acylation. So using aluminum trichloride as always. And what we'll be adding will be this. Okay. So we'll be right here after that. And so now what we need to do is reduce that ketone. And so sodium borohydride is good for that. And that's always used in methanol. So sodium borohydride and methanol will get us the alcohol there. Okay, and so now what we need to do is etherify that position, and that will complete our synthesis. And so we'll use sodium ethoxide as a nice strong base to pull that proton off. And then we'll use the chloride, the alkyl chloride of what we're trying to add, which would be that. And that gets us to our final product here, which is the starting material for the metathesis reaction. Okay, two things that I do need to address. The Friedel-Crafts acylation, that acylating agent that we're using there is going to come from this. So alcohols with fewer than 5 carbons. So this alcohol qualifies. And we'll start by oxidizing that. So chromium trioxide, sulfuric acid, and water, known as the Jones reagent or Jones conditions, to do an oxidation. And the point of that oxidation, rather than just using PCC, is that it gets us to the carboxylic acid rather than just the aldehyde there. And we want the carboxylic acid because then when we treat that carboxylic acid with thionyl chloride, we get the acyl chloride, the acid chloride. Okay, so there's where that reagent comes from. Our other reagent that we're using in the esterification can be prepared in a single step. And so this time we would have the alcohol here and just treat that directly with thionyl chloride. And that gets us to the alkyl halide that we need. Okay, so there's part A. part B. This metathesis, this ring closing metathesis product, unfortunately, is going to be a 7-membered ring. So bear with me while I draw that. Okay, so there we go, 7-membered ring. We would have a double bond right here. And then the rest of the molecule, of course, doesn't change. So here is our ring closing metathesis product there for B. Okay, and then the synthesis, pardon me, of the starting material. Again, we have to start from benzene. So let's start from benzene. Okay, the first thing we're going to do here is going to be to brominate that benzene ring. So bromine, iron bromide. Okay, now we can treat that with some magnesium metal, and now we've made a Grignard reagent. So we've made phenyl Grignard. Okay, so over here, I'm actually going to prepare an epoxide. So we'll start from ethanol. We'll treat that ethanol with concentrated sulfuric acid. That is going to affect an elimination to ethene, and we can epoxidize that using MCPBA. Okay, and that is going to get us oxirane. All right, and so now we can put these two reagents that we just made together. So we made a Grignard, and we're going to use that Grignard to open the epoxide that we made, followed, of course, as always, by a water workup. So I'll just put 2H2O down there. And so that is going to get us to here. Okay. And now with PCC, we can oxidize this alcohol to the aldehyde. Okay, so we have our aldehyde. Now we just need to make the acetal out of that aldehyde. And so to do that, we can use tosic acid. And we'll use what we want to make the acetal with. So okay. And so that is going to get us to our final product, which is the starting material for the ring closing metathesis reaction. So actually, I am just going to move this up just so that I have room. So I'll continue this arrow like that. Okay. Okay, so there we go. There's the starting material for the ring closing metathesis. So again, we prepared this by making phenyl magnesium bromide, the Grignard reagent, making an epoxide for that Grignard reagent to open, oxidizing that product to the aldehyde, and then preparing the acetal. Okay, and that's the answer to part B. Here again on the first page is part A, and that is the answer to chapter 26, problem number 47.